Hello everyone, and thank you for staying here for the last presentation. I'm Aida, Mostafazadeh Davani, and I'll be presenting our work with my brilliant co-first author, Sagar, who couldn't be here, and my collaborators, Sunipa and Vinod, who are here, and Shachi, who couldn't make it here either. Responsible AI practices focus on ethical, safe, and beneficial development and deployment of AI technology by building on innovations that are aiming to serve the society rather than just achieving the next technical endeavor. And by focusing on these ethical methods, the goal is to build trust in the users, which in turn will lead to wider AI adoption, which leads to having the positive impacts of the models reach more people. And especially by minimizing harms, and mostly either based on mitigating biases or more transparent and fair approaches, the goal is to maximize the net positive impact of the models. And together, these practices, ethical practices, form the foundations of the responsible AI, which leads to progress as well as safeguarding against harms and potential risks. As generative language models are getting more incorporated into our everyday lives, shaping our interactions, writing our emails, helping us with decision making, it becomes more important to reinforce to take care about the reinforced risks, such as the harmful biases, such as the stereotypes that can perpetuate harmful inequalities. And these risks become more pronounced in our setting. Detecting stereotypes and mitigating them in this setting becomes more important because these models are reaching more people and their harms become more severe. But one of the issues with this, detecting stereotypes, is that there isn't any the way we are conceptualizing the stereotype questions is not well established based on the linguistics approaches. Stereotypes are mainly defined as commonly held and oversimplified beliefs about different groups of people. In NLP approaches, stereotypes are often operationalized and reduced to pairs of identity terms and attributes, which I will refer to them as stereotypical associations. And NLP efforts rely on the social or reaching to different social settings to capture these pairs of stereotypical associations. And the measurements that are developed based on these resources usually try to capture the number of times these words appear in the training data, in language, or in the generated text. However, what we are getting from these numbers can be an over-prediction, because not all language is expressing stereotypes or try to influence these kinds of stereotypes. So as an example here, there are two examples of sentences mentioning the words women and nurturing. While both of them can be captured as examples of mentions of the stereotypical associations, only one of them is actually expressing a stereotypical belief or trying to influence audience by expressing this belief. So in this paper, we attend to the task of detecting the generalizing language. And by generalizing language, we refer to a broad statement about a group of people. So a sentence that is mentioning an identity and attribute can either be not generalizing. For example, in this sentence, there is no intention to saying that French people are rude. Or be generalizing. And if the sentence is generalizing, there might be different intentions behind the expression. The intention might be only to mention a stereotype, like people think French people are rude. Or it might be endorsing or promoting a stereotype or agreeing with a stereotype. We believe that this distinction can help us assess the harms of a stereotype that is being expressed in language as well. So to dig deeper into this question, we created the GeniL dataset in 9 languages: English, Arabic, Bengali, Spanish, French, Hindi, Indonesian, Malay, and Portuguese. And to do this, we relied on the multilingual Seagull dataset that captures a wide range of pairs of identity and attribute in different languages and different countries. We queried the MC4 dataset to capture sentences, a balanced representation of different stereotypical associations, leading to 50,000 sentences. And we had each sentence be annotated by at least 3 annotators, native speakers of the language, on whether they are generalizing or not, and if they are generalizing, whether they are promoting a stereotype or generalization, or just mentioning them. So in our analysis, we first looked for evidence for our motivation. So are stereotypical associations really always happening in a generalizing context, or is it something we can just overlook? Our results show that, in fact, the stereotypical associations rarely happen in a generalizing context. So the generalizing likelihood is really low among the items that we have in our data set. And in fact, when we focus on offensive attributes that are part of this stereotype, we still see that there isn't that much generalization happening. The next question is, okay, if there is a low generalization likelihood, is there a golden ratio that we can use to get from a stereotypical association appearing in language to getting to a real number of generalization? If there's always 10% of the samples are being generalizing, we don't need a generalizing language task. And is there a variance between, among the different associations, different identity groups, and even between languages? And our results shows that there are variations, both between associations, like how often different associations are being generalized, how often different identity groups are appearing in generalizing language. And in fact, there's also a variance in different languages. So we moved on to modeling, creating a generalizing language detector. One of our questions here is, can we use, for example, an English-based classifier for different languages? And the answer was not really. We tried 3 different approaches. First, only using the English data set to do the predictions for different languages. Then, second, augmenting English data set with translations of the different languages. And at last, using the multilingual data. And as you can see in these results, having the multilingual data in the training data set always leads to better performance. But as you can see, even when we are looking at the best models for each language, there is a reduce in performance for specific languages, here Arabic and Bengali. Interestingly, these 2 languages are the ones that led to highest annotator disagreement in our codings as well. So in our paper, we also expand on whether this is a data quality problem or a modeling problem, and how the future research should focus on different questions for these maybe low computationally resource languages. So the takeaways from the research is our GeniL dataset is the description of the task itself asks for more meaningful kinds of questions that we can ask during our evaluations, especially now that we are moving on to multimodal models. The concepts of a stereotype or social biases can become more convoluted. So asking more nuanced questions in this setting can be more very helpful. And future directions include not only spending time on the modeling side for different languages, but also capturing data that represent the real question that we have in hand. Applications of this task can also both be explored on safeguarding models, working on the outputs of models, but at the same time looking at the data curation approaches that we are currently using for creating benchmarks. Thank you. Our paper will also have a poster, and here's the data set on GitHub.
Okay, so my name is Ray. So I'm curious, like, do you guys have studied like who are the speakers or like authors from each of the language? For example, like I'm actually like Chinese ethics, but I also speak like Indonesian and Malay. But I think that when I'm writing in Malay, my own stereotype is more aligned to like maybe Asian Chinese kind of thing. So I'm not sure like if like your corpus have like identified like who are the authors for each of the data set?
Yeah, that's a great question. And for example, for two of the languages, for Spanish, we only relied on Mexican annotators, and for Portuguese, we only relied on Brazilian annotators to have like more geographical representation. But that's true, like there is no one-to-one relationship between languages and like countries, but we try to keep annotators in the same geographical context, maybe, but that's definitely something to explore when we talk about multilinguality, where we are focusing on when we are talking about a language.
Okay, thanks.